Hello and good morning. Today we are going to talk about some techniques for integrals. They are very important. And some technique for derivative, again, they are important, and domain and the range of this function. So we have what? We have trigonometric inverse, means that these six graphs that we taught about the sine and cosine. Today we are going to take the inverse, sketching the graph, and getting the derivative and integral. So do not forget about all these points. That's the object for today. We have the first important trigonometric inverse, sometimes inverse, like for example, sine inverse of x can be written as arc sine of x or small arc, like that. Both of them or all of them, they are the same. Understood? So during the exam, if you have sine inverse, means that you have arc sine. That's the first note. The second note, the important things in 7.6, we have a graph as usual. And after the graph, you have a domain and range of the function, these functions. Also limits, understood? Limit of these functions. Again, we have a derivative, and later we need the integral of them. So it's easy if at the beginning, if you have a graph, if you can catch the graph, if you can understand about the graph, the domain and range and limit are guarantees. Then later, if you control the derivative, so then you can control the integrals. So it is not hard, just need more attention. First of all, I'm going to talk about sine inverse of x. And the function of the sine is like that. Am I right? General form is like that. My question is what? Can we take the inverse of the sine? Do we have an inverse generally? Sorry? نقشك عكس الرتو. Why? Why? You're right, but why? Okay. We mentioned before. Yeah, we say that we have vertical line, horizontal line test for showing that your function is one-to-one or not. The first, we are going to check one-to-one, because if your function 7.1, we mentioned that, right? If your function is not one-to-one, it's impossible to talk about inverse. That's the beginning. Okay, so for that purpose, I'm going to cut, or we can say restrict, our domain from here to here, from pi over 2 to minus pi over 2. Understood? Okay. So we are going to talk about the specific interval. Why? Because we restrict the domain. That's very important for us. So the domain should be restricted. Now I have this function. This will be my future function. Here to here. Here is 1. Here is minus 1. And here's pi over 2. And here's minus pi over 2. So when we want to sketch the inverse, we should change these together. Please be with me, concentrate. It's the first one. It's very important because I'm not going to solve all of them because they have the same strategy. 1, 2, 3, that's enough for you. So we have 6, careful. So for that purpose, I'm going to change x-axis, here's y-axis and x-axis. I'm going to change the value over them. Like what? Like that, 1 and minus 1. Can you imagine? From x-axis to y-axis, or from y-axis to x-axis. Did you understand? What did I do? The first. Also for y-axis the same. We are in the pi over 2 for minus pi over 2. So I'm going to write down like that. Pi over 2 minus pi over 2. Sorry. You get the point? Yes. Good. Now it's time to what? To analyze, okay, careful, to analyze your behavior, your functions, how's the functions behaving like what? For example, but here, that one. In the first quadrant, I can see my function start from here to there. Understood? Okay. The curve is concave up to pi over 2. So I'm going to start from here. My graph should be concave up to pi over 2. You get the idea? Shall I repeat it? Right here. You can see in this curve over x-axis, my function is like that. The face of the function, let me say that, the face of the curve is 2 pi over 2. So, and the back of the function is to 1. That's why I'm going to draw it like that. Why? Because the face is 2 pi over 2 and the back is what? 2, 1. Understood, dear? I think now it's easier. How about in the second part, in that part, in the third quadrant? The face again 2 minus pi over 2 and the back of the curve 2 minus 1. So I say the face should be, or my graph should be like that. Why? Because the face to here and the back to here. Understood? So that's why I say the curve, if you have two curves, the first function is like that. Sorry. If the first function is like that, the second, sorry, this is the inverse. My function, if it's like that, sine, the inverse will be like that. Here's pi over 2 minus pi over 2. So here's pi over 2, here's minus pi over 2. Here's 1 and minus 1, here's 1 and minus 1. Understood, dear? This is very important because later you will tell me the domain and the range, not me, because you have a graph. Understood? So look at your lecture. You can see in the first table, you can see from here, we restrict the domain. Here we just restrict the domain. For the second part, in the down, here in this graph, we found the arc is founded here, the graph of the arc. Okay, sorry. Understood, dear? Easy. Just need more, a little bit work. Okay. Maybe you need more information about it. I'm going to give you more. So that's about the function. Later, we are going to select each one, each domain and range, okay? Because you have a graph. So for the second example, cosine of x. You know the cosine is like that. Am I right? Understood? So I'm going to restrict it from here to there. Understood? Why we restrict here? Because here from 0 to pi. Why you do like that? Because here is 1 to 1. The same reason, right? By horizontal line test. Understood? Now I'm going to change my function. Here we have from here to pi, okay, from 0, here's pi over 2. I'm going to select all important points, and here you have 1 and -1 on x-axis. Am I right? No, on y-axis. So I'm going to change x to y. I'm going to change x to y. I have 0, I have pi over 2, and I have pi. Understood, dear? Here's your points. Understood? Y from x-axis to y-axis. Now also I have 1 and -1. Am I right? You got it? Good. So your graph start, you can say like that. My graph, I can change it to 2 or 3 parts. I can understand by many methods. For example, I say my graph start from 0. Here we are. Start from 0 and 1. So start from 0 and 1 and cross pi over 2 like that. Am I right? Here I start from this point is what? Point of 0 and 1. How about that point? 1 and 0. So I start, instead of starting from 0 to 1 to 0 and pi over 2 and 0, pi over 2 and 0, that point will be pi over 2 and 0. Here. So I'm going to change it from 1 to 0 to 0 pi over 2. So that's why I start from here to there. Any question? How about the second part? Can you imagine? Instead of here to here, this point will be the end point, and it will be pi over x-axis and -1 over y-axis. So that point will be what? -1 and pi. Means that -1 over x-axis. That's why my graph will be like that. You got it? So I use the point here. This is the first strategy. No, for the second strategy, maybe the other students say, no, I'm not going to do like that. I'm going to use the previous one. Here's x, okay. Here's y. I'm going to here. Here's x, okay. Here's y, 0, pi over 2, and pi, okay, here will be 1. Here's is -1. So from 0 to 1, yeah, you can see here, from 0 to pi over 2, the graph face is what? Is on with 1 and back over pi over 2. So my face graph is here, and the back will be over my pi over 2. And from here to here, the face of the graph is 2 pi and the back to -1. So that's why the face should be 2 pi. Here's pi, you know. The face should be 2 pi and the back to -1. Here's the face, here's the back. Understood? That's another strategy. Up to you, whatever you like. This is the second example you can see from here. Here's the graph. Okay, good. So later I'll tell you what's the question, okay? Just let me give you the clue. Later I say my question will be like that or like that or like that. Understood? So for example, I say y is equal to sine, let me tell you now. Y is equal to cosine of the x. Find the inverse. Sketch the inverse of the function. That's the first. Or maybe I say limit of the inverse. I'll give you another. Or I say sketch the graph, find the inverse, sketch the graph, and select the domain and range. The same. all of them, all these parts I mentioned here, depends on the graph. Do you remember that? All these depends on the graph. Careful. These all one package. If you know about the graph, you can answer all of them. Later, we are going to how to answer those questions. Understood, dear? So tell me about tan. Yalla, it's your turn. Find tan, please. There. Here's the graph of tan. Pi over 2 minus pi over 2. So tell me that's a tan of x. So sketch y equal to tan inverse of x. Yalla. There. Try to do it, please. Do not look at your lecture note because I wanna to get more. What do you say? Look at here. As we mentioned, the first of all, review the value, reverse the value. Okay, reverse the value. What do you mean by reverse the value? Here's pi over 2. Here's minus pi over 2, and I have an asymptote. So I'm going to sketch the asymptotes here, like that. That's why I say 90%. You need to sketch the asymptote also. Then the shape, the phase to y-axis phase, the back to asymptote, right? Back to asymptote. So I'm going to, I say the shape should be here, the back should be there. Why? Because I'm going to change it. Phase to x-axis, y-axis, here phase to x-axis. And again here, we have phase to negative y-axis. So here's phase to negative x-axis and back to asymptote. You can see the same. Do you know how to do it? Do not forget about pi. Change at the beginning, change the value, reverse the value of x to y, then later shape, phase, and back. And I don't know, there's a strategy to do it. Some students do something else. I don't know. The important things here, what? To sketch the graph. Now cotton, I'm going to leave the cotton for you, is the same. Cotton is like that, okay? Understood. And how about second of x? Look at here. We have the second is like that. Do you remember that? Here's -1, here's 1. And here's asymptote, pi over 2. Here's another asymptote, minus pi over 2. But when we restrict the domain, we have such graph like that. Careful. Here's 1, here's pi over 2. And here's pi, here's -1. Careful. Okay. If I want to put the good point or to select the point, I'm going to write the point like that. I say 0, here's 0, you know. 0 and 1, that point. How about that point is what? They? Payu, Saravachana? -1, thank you. Okay. Understood. So I'm going to find the inverse of that function. So the first of all, I'm going to change the point to what? Instead of 1 and -1, I have 1 and -1. Here we have what? Pi over 2, am I right? The asymptote. Also we have what? We have pi. You get the idea? Hello? Can you imagine how to change it? Good. So how we sketch? I'm going to my strategy. I say starting from 0, 1. So starting from 1 and 0, right? To where? To the face to the axis, the back to asymptote. So the face to the axis, the back to the asymptote. Am I right? Do you agree with me? Hello? Good. How? Because I can see here, face to here, back to here. That's easy. That's the first part. How about the second part? Give me that part. They. Think about it. Imagine. Above asymptote. Good. And like that. Exactly. So I'm going to start with the point. The point is what? Pi minus 1. So I'm going to write what? Minus 1 and pi. We should reverse it. X to y, y to x. Okay. Then come to down to asymptote, right? Why? Because here the back to asymptote, the face to up. So here's the back to asymptote, the face to up. Understood? It's not easy, but it's not difficult. Just need to sit down. You have 6 graphs. First, find the domain that they are one-to-one, then change one by one of them. Understood? Change one of them. So that's all we have here. Look, here's the domain. Here's the space that your function is one-to-one. Here's again the space from 0 to pi. Here's from minus pi to pi over 2. Here's from minus pi over 2 pi over 2 that you did it. Here's we have cotan. Cotan is like that. So I'm not going to take the other one. Just I'm going to take the first part. Why? Because the one-to-one again, you can see the one-to-one. And here's the second that we did. And that one is homework for you. Understood? Because cosecant is like what? The graph of the cosecant. The graph of cosecant is like that. Easy. You saw that one before, right? In chapter 1. Understood? In chapter 1, we have these graphs. Hello? Understood, Kaka? Yes. Kamian? Falan Keshaman? Yes? Okay. يعني ما بس أمانة أما خوارو هيك يعني هيك شيء نيجي يعني هيك مجالي يعني بيلا وكو خوي ديكيتو. Why? Because you have that one, then the inverse of that one is equal to 1. Like شون يبرو أوا أما خوارو أوا برو you cannot. Okay, you are right. You are right. The back is to the asymptote. You are right. But my question is that one intersect any axis? So why that one should be intersect that axis? You got it? Intersecting بوشي أرى. أجر أما أوار رشتو intersecting بينما أوهاتو تخواره. You are right. لو كانت intersecting x axis يكرو بويك أما أكيوشم intersecting y axis يبيعكم. But the body أشتري now, so we have no that one. Okay, we cannot do it. But maybe you ask me, that one is true in somewhere else. لو أجيب برسيقي check a sign بقى ليرو والgreen بقى ليرو النبي بقى ليرو بيونيا. Am I right? أمان ختايم النية. This is the international contract that we say we are going to use the sign inverse to here. Why? Because to unify the calculator. You know what? To unify the calculator, to all calculator to be the same. Because if you say I'm going to take the sign instead of here from minus pi over to 2 pi over 2, I'm going to take it from pi over 2 here. 2 here. You are right. Also, you can take an inverse here. But internationally, we say that part, not that part. Understood? Do you know what I mean? نقشه ساین اتوان لیرش خواری گیرم. اما ساین گرو زور زور دور دریاش اتوان خولیرش خواری گیرم. لام پارچه‌اش from pi over 2 to pi is also a 1-to-1. So because the 1-to-1, we can take a inverse. But internationally, no, we see from that part. Understood? Hello? Good. No, you don't need to. You don't need to think about it. Okay? Even for exam, that's the standard inverse. Otherwise, we have non-standard. So, okay, the same. Good. Do you have any question? No. So you know the graph, you know how they are 1-to-1, how we restrict the domains, how we took them. That's very important. You can see from here, everything is clear. Now I'm going to give you the clue. Now we are going to the second step, answering domain, range, and limit. Understood? Good. So it's your turn to tell me. Tell me about the domain of that function. Yalla. Firm. Sorry? Inverse, that one. -1, 1. Close or open? Close. Understood. How about the range? Yes, from -pi/2 to pi/2. So domain of this function is like that. Range of this function is from -pi/2 to pi/2. Close. Understood? Easy. Tell me about sine inverse. Cosine inverse. Yalla. Domain. Yalla, the domain will be red, the range will be green. Yalla, domain de kyo bakıyor? Again, -pi, right? How about the range? 0 to pi. Only 2 pi. Okay, 0 to pi, right? From 0 to pi. Understood? Good. How about domain of here? Day. Morning. Yes. Domain is R, -infinity to infinity. You can see from here, -infinity to infinity. So that's why we have -infinity to infinity here. How about the range? But open intervals. We have pi/2 -pi/2. Understood? It's not closed because we have asymptote. Open the value asymptote. Easy. Yalla. The الرسم اقصاكي بوخو. Domain of that one. Or -1 to -infinity, okay. Union 1 to infinity. Thank you. So شو يعني؟ I'm intervality يعني بينه, right? So you can see from here to there, from here to there. How about the range? Yes. Okay. Exactly. Thank you. So you have from 0 to pi/2. And again, from pi/2 till pi, closed pi, right? And that one, I'm going to leave it for you. And that one, I'm going to leave it for you. Because you can answer. It's not a big deal. Understood? Easy? So that's why I say, if you want to understand this section, just sketch the graph. Sketch the graph. Later, you can answer everything. For example, I'm going to answer that one in the calculus 2, especially we need. Tell me about that question. Yalla. limit of tan inverse x approach to infinity positive. There. Here's the graph and answer. Pi over 2. Why? Because I am going to positive infinite, right? So my graph is going to where? To where? Up to y, pi over 2. How about limit of x approach to minus infinity, tan inverse of x? Yalla. Minus pi over 2. I am going to minus infinity. The graph is going to where? Minus pi over 2. That example I am going to use in chapter 8, section 7. So careful. Chapter 8, section 7, it will be in Cal 2. Don't worry. Okay? So that's why I say we need that one. You have an improper integral. During that improper, we need the limit. During the limit, we have that graph. So that's why they are the chain. That's why I'm going to slowly with you. I tell you everything because there we have we don't have a detail. We just try to solve it. I'm not make you afraid, but I'm telling you, you need to control it from here. That's it. You should study today or tomorrow. You know, so you should to do it from now. Easy. So tell me about limit, for example, here, whatever you want. For example, here, arc cosecant. I say limit x approach to infinite, for example, cosecant inverse of x. Whatever you like. I change the question, up to you, because I have a graph. I don't care. Change it to 0, change this one to 0, change that one to minus infinity. I don't care because I have a graph. Understood what I say? Actually, if I am not sketching the graph, also I cannot answer this limit, you know? Because I am not memorizing everything. I know about the techniques. That's why. So I'm recommending you to use the same. Yalla, equal to what? 0, yes, you're right. I'm going to infinite. So the graph is going to where? To be close 0. How about minus infinite? The same, right? I'm going to minus infinity, but the graph is going to 0 again. Understood? Do you want to ask me any question or do you want any things? I think it's easy. Why is easy? Because need work. That one. Yalla. Limit of x approach minus infinite second inverse of x. Yalla Jamaat. Yes. Pi over 2. I'm going to minus infinite, but the graph is coming back to here, decreasing to here. Pi over 2. The same thing is true for here. You got it? Good. So that's all about the graph, domain and range. Do you have any questions? Feeling good? Good. Before the rest, because I'm going to give you the rest, I'll give you two things. The first, I gave you the table. Do you remember that? For example, we say second. For example, we say sine of pi over 4 is equal to square root of 2. Do you remember that? I gave you the table. Now tell me about sine inverse of pi over 2 is equal to what? That one. Reverse it. Directly reverse, you don't need to think about it. Understood? If sine of 0 equal to 0, so sine inverse to both sides, is equal to sine inverse of 0. So sine inverse, I'll get inverse, and sine of here, so I can say sine inverse of 0 is equal to 0. You get the idea? No, because I was so fast. I know. Even you say yes, I know you didn't get it. Okay, am I right? Well, because I can ask you now. Okay. You are thinking about the rest. That's fine. So look at here, Kaka. We see that sine of pi over 4 as an example is equal to square root of 2 over 2. Now to get the inverse, I'm going to take the inverse to both sides. Sine inverse 2 here, sine inverse 2 here. That's why sine inverse and sine, they are inverse to each other. And you know, if inverse circle f will give me what? X. So here I can say, sorry, these two will cancel, eliminate, and pi over 4 remains. So you can ask me sine inverse of square root of 2 over 2 is equal to what? I can say is equal to pi over 4. This is true for the rest others, all values. This is the first point I want to share with you. The second point, this identity and this one is not very important actually. Just study two of these that I gave you. So you have that one for my point. You can take it. Just look at here. We don't need these identities. The important things here to give you this table. Actually, I want to just give you the table. Where's the table? No. Here's the table. This is very important. Today, we are going to use this table 7.3, because maybe in the 7.4 we have the inverse, anti-inverse of that one, because we have an integral. Look at here. I'm going to summarize for you. Just try to focus on these three, no more. And can you tell me why? Derivative of sine inverse is equal to that one, derivative of tan equal to that one, derivative of cos of second is equal to that one. Can you tell me why I neglect that one and that one and that one? Why? Yes? No. Look at it. Just look at it. Why I use the first, why I neglect the second? Yalla. Day. Hello? It's in front of you. Huh? No. No. Yes, just multiply by negative. Right? What's the difference between the first and the second? What's the difference between the third and fourth? Huh? What's the difference between the fifth and the sixth? Just negative. So that's why I told you to do like that. So I'm going to give you the clue. First, y equal to sine inverse of x. Careful, Kaka. Y equal to tan of x. Y equal to second of x. Tan inverse sakani. Now I'm going to find the derivative. So as I told you, we have a graph domain range. Now it's the fifth and the fourth and the fifth one. They are important, derivative and integral. So I'm going to just give you the rule that we have here. You can see. Okay, I see is equal to, if it's a u, that be the function, we see is equal to 1 over 1 minus u square u prime.
For the second, we say 1 over 1 plus u square u prime. For the third one, we say 1 over u square minus 1 u prime. U prime means what? Du over dx. Okay, I'll give you 10 minutes to take a rest.